Hello everyone. In this session, we will revise the fractions. We have learned about fractions in our earlier standards. So what we are going to do in this session is we are going to revise whatever we have learned till now. What is fraction? Fraction is part of a whole. Here there are two terms, important terms here, part and whole. So what exactly are they? Let's talk about you taking one example. So let's say I have one cake. That is my whole cake. Now I'll divide this into three equal parts. Again, the equal word here is very important. So I'm going to divide this cake into three equal parts. Each part is equal in size. One part of it, I take it for myself. What is the fraction of cake I have for myself? So to do that, to find the fraction, I'll talk about how many parts I have taken. I have taken one part. So part of a whole. And from how many total parts were there in a whole? When this cake was whole, how many total parts were there? 1, 2, 3 of the same size, 3 parts. So what I say is I have taken 1/3 of the cake, 1/3 part of the cake. And here 1/3 is a fraction. The number which is part, this number we call it as numerator. And the number below, that is the whole, we call it as denominator. Now let's talk about types of fraction. So based on the value of numerator and denominator, we have two types of fraction. One is called proper fraction. And another is called improper fraction. How do we? So whenever we have the numerator is smaller than denominator, so that upper part of your fraction is smaller than the lower part. So numerator is smaller than the denominator, we call it proper fraction. When the numerator is greater than the denominator, it's called improper fraction. So to give an example, if you see here, if I have a fraction 3/4, now 3, which is numerator, is smaller than 4. Hence, this is a proper fraction. But if I had 4/3, now in this case, numerator is 4 and which is greater than 3. And hence, this fraction is called improper fraction. Now, there is one more type of fraction called mixed fraction. Mixed fraction, more than a type, it is a different way of representation of improper fraction. So the improper fraction 4/3 can also be represented as 1/3, and it will be called mixed fraction. What we do here is, here 4/3, what is 4? 4 is the dividend. And we have 3 as divisor. When we do this division, what we get is we get something called quotient and remainders. If it is not a perfect division, we get remainder. The mixed fraction is always, when we do this division, whatever quotient we get, quotient comes here, then the remainder comes in the top and divisor. Okay, so if I have to put it in, divisor comes here. This is divisor and quotient remainder upon divisor. That is what is the mixed fraction. Then we learned about addition and subtraction of a fraction. And we know to add or subtract a fraction, denominator has to be same. So if I have a fraction 2 upon 9 and I have fraction another fraction 3 upon 9. So I have the denominator same. In that case, I can add these fractions directly. So in the answer, the denominator stays same. In addition or subtraction of a fraction, denominator stays same. It does not change. So denominator stays same, 9, and we only add the numerator. So 2 plus 3 is 5, 5 upon 9. Same way, if I have 5 upon 9 minus 2 upon 9, denominator will stay same as 9. 5 minus 2 is 3. What happens if the denominator is not same? So if I have a fraction 2 upon 3 and the another fraction is 1 upon 4. If I want to add them, what should I do? I should make the denominator same. So in that case, what I am supposed to do is find the LCM of the denominator. LCM of denominators. So LCM of denominators in this case is 12. So the 2 upon 3 fraction, I have to find the equivalent fraction. So I have to convert this 2 upon 3 into an equivalent fraction who has denominator as 12. So to get a 12 denominator here, what I need to do is I need to multiply 3 by 4. 3 into 4 is 12. In that case, to find equivalent fraction, I have to multiply 2 also by 4. So 2 into 4 I have to do. So what actually I am doing here is, this 3 I am multiplying by 4 to get 12. So in that case, I have to multiply the numerator also by 4. So 2 into 4 is 8. So my equivalent fraction of 2 upon 3 is 8 upon 12, which has denominator same as LCM. So same way I will going to find for 1 upon 4. So 1 upon 4, what I need here is 4 multiplied by 3 gives me 12. So I'm multiplying by 3. So then I have to multiply 1 also by 3. So 1 into 3 gives me 3 upon 12. Therefore, 2 upon 3 plus 1 upon 4 becomes equal to, 8 upon 12 plus 3 upon 12. And hence now, because the denominators are same, what we do is the denominator stays same. The denominator will stay same, 12, and we just add the numerator. 8 plus 3 is 11. So I get answer 11 upon 12. Now let's do subtraction of these integers. So even for the subtraction, the initial steps are same, that is to find the LCM, then convert this 2 upon 3 into an equivalent fraction which has the denominator as 12. So 3 into 4 is 12, therefore 2 into 4 is 8, and 1 upon 4 becomes 1 upon 4 also. Same way, 4 into 3 is equal to 12. So 1 into 3 is equal to 3. So I get equivalent fraction. Now I'm going to do here subtraction. So I want 2 upon 3 minus 1 upon 4. I want. So 2 upon 3 minus 1 upon 4 is equal to 2 upon 3 is converted into 8 upon 12. That's the equivalent fraction, minus 3 upon 12, because 1 upon 4 is same as 3 upon 12. Now again, the denominator stays same, and 8 minus 3 is 5. 5 upon 12. So let's take example of mixed fractions. So if I have 1, 2 upon 3, and I have to do plus 3, 1 upon 4. Now in this case, because they are mixed fractions, there is a way to directly add the whole numbers and the fractions, but till the time you are very comfortable with fractions, I would say that you should follow a little lengthy method, but a sure shot method. So what we do first is convert these mixed fractions into improper fraction. So to convert mixed fraction into improper fraction, what we do, the mixed fraction is represented in this way. So to convert it into the improper fraction, what we are supposed to do is q into d plus r upon d. So we have to multiply 3 into 1. 3 into 1 is, so 1, 2 upon 3 is equal to 3 into 1. Okay, so q plus 2 upon 3. That is, as per BODMAS, the first comes multiplication in this case. So multiplication is 3 into 1 is 3. 3 plus 2 upon 3, so which is 5 upon 3. Same way, if I do 3, 1 upon 4 is equal to 3 into 4 plus 1 upon 4. 3 into 4 is 12. 12 plus 1 upon 4, which is equal to 13 upon 4. So what we have done is we have converted the mixed fraction into improper fraction, and now we will do the addition. That is equal to 5 upon 3 plus 13 upon 4. So I'm going to take these up. Okay, so let me get rid of these also now, because we have already taken them. Now what we need to do is 3 and 4 different denominators, so I have to find the LCM. If you see here, the LCM of 3 and 4 is 12. So I will convert 5 upon 3 is equal to, I have to convert it to 12. So 3 into 4 is 12. So 5 into 4. 5 into 4 is 20. So 20 upon 12. Same with 13 upon 4. Again, I have to convert it into denominator as 12. 4 into 3 is 12. So 13 into 3 is 39. So this becomes equal to 20 upon 12 plus 39 upon 12 equal to, now denominator is same, so denominator stays same. 20 plus 39 is 59. So answer is 59 upon 12. Now we have to convert it into the mixed fraction. So we know 59 upon 12 is 12 fours are 48 is 11. So now q is, and this is our d. So we have to write in QRD format. So 4, 11 upon 12. That is our answer. So let's do the shortcut method here, where we do, what we do is we add the whole numbers. So I can do 1 plus 3, the whole part of it, plus 2 upon 3 plus 1 upon 4. So now that becomes equal to 4 plus 2 upon 3 plus 1 upon 4. Now if I add 2 upon 3 plus 1 upon 4, 4 plus, here I have to do convert it into an equivalent fraction. 3 4s are 12, so 4 2s are 8, plus 4 3s are 12, so 1 3s are 3. And that gives me 4 plus 11 upon 12, and that is equal to 411 upon 12. So there is a shortcut method for doing this. But as I told you, what happens if this answer If this answer is greater, if this is greater, which is an improper fraction, then we'll have to do something else. So let's take one example. 1 2 upon 3 plus 2 3 upon 4. So as per our shortcut method, it will be equal to 1 plus 2, the wholes we add, and then we add the fractions. 1 plus 2 is 3, simple. Now inside the fractions. Inside the fractions, we know that 4 and 3, the LCM is 12. So it is 12, LCM is 12. Now, how do I convert? This 3 has to be converted into 12. 3 into 4 is 12. 3 4s are 12, so 2 4s are 8. Comes here. 4 3s are 12, so 3 3s are 9. Okay, so it becomes 3 plus 9. Now, same denominator, so denominator stays as it is. 8 plus 9 is 17. 17 upon 12. So do we stop here? No, we can't stop here because this is an improper fraction. So improper fraction has to be converted into a mixed fraction. So it becomes equal to 3 plus, now if I have to convert improper fraction, 17 divided by 12, 12 ones are 12, I get remainder as 5. So this is my Q, this is my R, and this is my D. So QRD, writing in form of QRD, it is 1, 5 upon 12. Now we have one more whole. So this has to be added into the whole. So it comes 3 plus 1 is 4, 4, 5 upon 12. So this is something which you need to remember whenever you are using this method of adding the wholes. We need to convert the last fraction. If it is improper, we need to convert into a mixed fraction and add that whole into our earlier wholes also. At this point in time, please do not use this method for subtraction. Comparing fractions. We can compare fractions using 4 rules. First rule, if the denominators are same. So I have a fraction 4 upon 11 and another fraction 5 upon 11. The denominators are same. If the denominator is same, so if D is same, denominator is same. If denominator is same, what we do is greater the numerator. So whichever numerator, whatever we have a numerator is greater, then that fraction is greater fraction. Okay, so in this case, which is the greater numerator? 5 is a greater numerator, therefore this is greater. Okay, now we have second, this is rule or situation 1. Second situation where the numerators are same. So if I have 4 upon 11 and 4 upon 12, I have two fractions to compare, 4 upon 11 and 4 upon 12. In this case, numerator is same. So if numerator is same, greater the denominator, smaller is the fraction. So now in this case, what are the denominators? 11 and 12. Which one is a greater denominator? 12 is a greater denominator. So the greater the denominator, smaller is the fraction. So in this case, 4 upon 12 is smaller. Now, why is this happen? Why does this happen? Because we have, let's say we have a cake, 2 cakes. Okay. Let's say in this case, I make only 2 pieces of this. I make 3 pieces. Now, in both cases, I take 1 piece. So what is the fraction I have taken here? I have taken 1 upon 2. And here I have taken 1 upon 3. Now tell me which one is greater in size. It's obvious, it can be visibly seen that this is greater. Why? Because we have made less number of pieces. Less number of pieces means the denominator is smaller. So the smaller denominator is greater size of the piece. And hence we get this rule here. Rule number 3 is if we are comparing a proper fraction, if you are comparing a proper fraction with improper fraction, if you're comparing proper with improper, improper fraction is always greater. Improper is always greater. So if you compare proper, improper is always greater. So you can use these three methods to find or to compare the fractions in a fast track mode. Now, what if none of these situations are true? So if I have a fraction, let's say 3 upon 4 and 5 upon 7. Now, do I have numerator same? No. Do I have denominator same? No. Do I have any of them improper and other proper? No. Both are proper. So I cannot use these three methods. So just for comparing the fraction now, what you do is you do a cross multiplication. So 3 into 7 is how much? 21. So 3 and 7, 21. So you write that this side. Okay, so 3 multiplied by 7 and 5 multiplied by 4, 20. Which one is greater? 21 is greater than 20. So in that case, 3 upon 4 is greater than 5 upon 7. So this is our rule number 4 for doing comparison of fractions in a faster way. Let's solve a few examples from your exercise 2.1. So 2.11, let me take 2 minus 3 upon 5. Now if I do 2 minus 3 upon 5, that is equal to 2, which is a whole number, is also represented in fraction form as 2 upon 1. Any whole number can be represented as fraction with denominator as 1. So 2 upon 1 minus 3 upon 5. Now we have to do the denominator same. So 1 and 5, the LCM is 5. So LCM is equal to 5. So LCM is 5. What we'll do is here, we'll make this denominator as 5. So 1 has to become 5. 1 has to become 5 means we have multiplied 1 by 5. We have to multiply 2 also, the numerator also by 5. And same way, 5 remains as it is. So 3 remains as it is. So we have 10 upon 5 minus 3 upon 5. Denominator same, the denominator stays 5. 10 minus 3 gives us 7. So answer is 7 upon 5. Let's do one more. Let's do 8 1 upon 2 minus 3 5 upon 8. Now we have mixed fractions and subtraction. We talked about it. We will not be doing it with the shortcut method. We'll use the normal method. So first we'll convert 8 1 upon 2 into improper fraction. So for improper fraction, what we do is we multiply the denominator with the whole. 8 2s are 16 and we add this 1. 8 2s are 16 plus 1, 17. So this becomes 17 upon 2 minus here 8 3s are 24 plus 5, 29 upon 8. We have different denominators, so we need to find LCM. Because 8 is multiple of 2, the LCM is going to be 8. So LCM is equal to 8. So what happens here? 2 converts into 8. 2 into 4 is 8. So 17 into 4 is 68. 17 4s are 68. Minus 29 upon 8. So for denominators are same. So in answer also denominator stays same, 8. 68 minus 29 is 39. So 39 upon 8. But we are not going to stop here because it's an improper fraction. We have to convert it into mixed fraction. So how do we convert? We divide 39 divided by 8. 8 4s are 32. 7 is remainder. So this is my Q, this is my R, and this is my D. So in QRD format, 4, 7 upon 8. So this is my answer, 4, 7 upon 8. Salil wants to put a picture in a frame. The picture is 7, 3 upon 5 centimeter wide. To fit it in the frame, the picture cannot be more than 7, 3 upon 10. How much would be picture? How much should the picture be trimmed? So what we have is the frame is this much and the picture is a little bigger than that. And the picture is a little bigger than that. So we have to trim it. So to do that, let's write the givens. The picture's width. So width of picture is equal to 7, 3 upon 5 centimeter. And the width of frame is equal to 7, 3 upon 10 centimeter. And so we want to find how much to be cut. So the difference means subtraction. So therefore, the picture to be cut is equal to 7, 3 upon 5 minus 7, 3 upon 10. Because picture is greater and the frame is smaller. So we are subtracting from the greater, the smaller one. So that is equal to, now we'll convert it into improper fraction. So 7 5s are 5 into 7, 35 plus 3. So we always go from down to up. Okay, so here multiplication, here addition. So 5 7s are 35 plus 3, 38. 38 upon 5 minus 10 into 7 is 70 plus 3, 73 upon 10. Now they are not same denominator, so we have to make the denominator same. But here we see 10 is multiple of 5, which means the LCM is going to be 10. LCM is going to be 10. So let's convert this into 10. 5 2s are 10. So 38 2s are 76. So 76 upon 10 minus 73 upon 10 as it is. Let's do the seventh one. Ritu ate 3/5 part of an apple and the remaining apple was eaten by her brother Somu. How much part of the apple did Somu eat? And who had the larger share? And by how much? So we have there 3 questions here. So first, let's write the givens. Ritu ate 3 upon 5 apple, part of the apple, 3 upon 5. Okay. So what is the remaining apple? Therefore, remaining apple is going to be equal to the complete apple, which is 1 minus what Ritu ate. Ritu ate 3 upon 5. So 1 minus 3 upon 5. So 1 is also represented as I told you, whole number is represented always as 1 upon 1. So 1 upon 1 minus 3 upon 5. So making the denominator same. 1 and 5, the LCM is going to be equal to 5 because 5 is multiple of 1. So we get LCM as 5. So denominator we have to convert as 5. So 1 into 5 is 5. 1 into 5 is 5 minus 3 upon 5. So that is equal to 5 stays as it is because the denominator is same. 5 minus 3 is 2 upon 5. So remaining apple is 2 upon 5. So therefore, Somu ate 2 upon 5 apple. Now who ate more? So we have to compare 3 upon 5 and 2 upon 5. We know that the denominators are same, then higher the numerator, greater is that fraction. So 3 upon 5 is greater. Therefore, Ritu ate more. But by how much? So let's do it in others. By how much? So Somu ate 2 upon 5. Ritu ate 3 upon 5. So who ate more? We know that Ritu has eaten more. So how much more? So therefore, to find how much more, Ritu ate, what we have to do is we have to do subtraction. So Ritu ate 3 upon 5 minus Somu ate 2 upon 5. Denominator same, so answer also denominator stays same. 3 minus 2 is 1 upon 5. Therefore, Ritu ate 1 upon 5 part more than Somu.